Hey everybody, we're gonna give it an extra couple minutes to see if anyone else joins, and then we'll go ahead and get started. Feel free to post your answers to this if you can figure out what the question mark is. Okay, we're gonna go ahead and get started. Welcome everybody to lecture 13 about MongoDB and authentication. So before we get started, does anybody know what the answer is to this little riddle? Anybody want to say in chat? It is really hard, I'll be honest. So I'm gonna be a little surprised if you guys get it. Anybody? It is 1 through 9. It's number 1 through 9. That's true. The right answer is 4. So if you look at it, you multiply the first column by the second column and you get the last two columns. So 9 times 2 is 18, 6 times 4 is 24, 5 times 7 is 35, and then 8 times 8 is 64. I got that one from the little Mensa challenge. I did not figure this out my first time either. I had no idea. Anyways, let's jump right into it. But before we do, does anybody have any questions about the course, anything else going on? Broad questions. Go ahead and say anything. Okay, I will be looking at chat throughout the whole lecture. I want this to be a really interactive lecture. So if you have any questions on what I'm presenting or anything at all like that, please say so in chat and I'll address it live as we go on. So the main portion of today's lecture is going to be a live demo of building a Express and MongoDB app that can do user authentication. And going through that, I'll be showing you some little tips and tricks and some other little things into that. And to start off, we'll have a little short lecture about that. So let me help do this. So last lecture, we talked about HTTP, REST, and Postman. As a reminder, HTTP is the communication protocol that computers use to talk to each other across the internet. Every computer uses it. It's the main way that you can go to a website and websites can send information back to you. REST is the architecture that some servers use to design their backends. It's a set of principles that allow for a REST API to be kind of common space and for clients who use or are using their API to know how the API is going to work. So it's a set of principles you don't have to follow, but by building a RESTful API, it standardizes your API and makes it a lot more easier to use. And then finally, last lecture, we used Postman to make some HTTP requests and view those responses from APIs in a very structured and easily formatted way. So as a reminder, this is kind of what that process looked like. Can you guys see my mouse, by the way, if you see me moving around the screen? Yeah, awesome. So as a reminder, this is you going on your computer. And if you wanted to go to a website, you would make an HTTP request to the website. It would go across the internet, hit the web server's API, which would then take that request, format the HTML that you want to see, the CSS and JavaScript, and then send that back into an HTTP response. And then the component we're going to be talking about today is for servers that have logins like Reddit or Facebook or something like that. How do they know that you are who you say you are? So we'll be talking about that implementation as well as how servers talk to databases and store your information. So as a recap about Express, I know we've had a couple lectures about this, so this will be a little quick. Express is the backend framework that Node.js uses to create web applications. It makes it a lot easier to create web applications, and a lot of different websites use this, like the Poke API we saw last week too. This is an example of a simple Express application where we're importing the Express library, initializing an Express application, and then defining the routes for our app. In this lecture, we're going to get a lot more in depth about Express, talking about middlewares in Express, creating our own middlewares, and then creating our own routes for user authentication, logging in, and getting different results back from our database. Speaking of, what are databases? So databases are an organized collection of structured information at their core. And there are two main types of databases that you'd see in your everyday life. The first type is an SQL database. This can be thought of as an Excel sheet where you have columns in the Excel sheet and the rows are the different entries into your database. So each column could describe a specific part of each row, where it's like a name, an email, a password, and then each row would be one entry in that database. So some examples of SQL databases you might see is MySQL, PostgreSQL, and then Oracle's SQL databases. The other type of database you could see is a NoSQL database. These are a little bit more like JavaScript's objects, where they can have custom schemas. They're very flexible and very dynamic, where if you wanted to add more information into your database, it's very easy to expand. And then they also have different ways to search through the databases. So, oops. So the type of database that we're going to be talking about today is MongoDB. And this is an example of a NoSQL database. So kind of following that object-oriented type of structure. So it's a NoSQL database that's super easy to use. We'll be using it today in our little demo after this. And to show you real quickly, the rest of this lecture is going to be a demo on how to use MongoDB and how to make an application that does what we said it was going to do earlier. So here I'm pulling aside this right here. Okay, so this might look very complicated, but I'll explain through it all. So this is MongoDB's website, and I've created basically a database here that we're going to use as an example today. So in this database, we can see there are all these collections, which can be thought of as different tables of information in a NoSQL database. So each right here, we are on the listings and reviews page, and MongoDB has this as our first entry. So the entry into the database has an underscore ID, which is a unique identifier for that entry that can be referred to identify it in the database. And then it has a bunch of key value pairs that specify the information that's being stored in the database. So this is a sample database of Airbnb's listings and reviews, where this entry has a listing URL, the name of the listing, a summary, some descriptions about it, different notes. And with MongoDB, different entries can have different key value pairs like this. So there's actually a bunch of fields on here. You can also dynamically store objects inside of objects. So we can think of this top entry as an object. And then this key value pair is the key of images to another object that then has an image inside of it. As well, a NoSQL database can store arrays inside of itself, where the amenities are listed out in an array form here. And then each object that is stored in this collection is its own unique, each entry is its own unique object in this collection like this. So this could kind of give you a little bit of a mental picture for what a NoSQL database kind of looks like. And then here it looks like we can search for different fields. So maybe we can look for, if we want to search for a specific URL or a specific entry, we can search by its name. So we can have name and then its value. And then see that we can then query our database for this right here. So this is an example of finding one specific instance of a entry in our database, and it's going to be what we're using in our demo today. So let's hop into the demo. It's going to be all from scratch, so I can show you the full process of going from nothing all the way up to having a working backend database. And again, if you have any questions as we go along of why did I do it like this? What does this specific line mean? Please feel free to say it in the chat and we can talk about it from there. So the first step is you need to make a directory for where you're going to have your database, for where you're going to have your application. So I'll just make a directory here and then go inside of that directory. So now we're in the lesson 13 folder. And then from that, we're going to do npm init to create a new node project. So this is going to ask us some things like our package name, the version, and I'm just hitting enter here to go right through it. What our entry point is how we're going to start our application, how we're going to run it. We don't need a Git repository, so we can just skip through all this stuff. And then here it's going to create our package.json, and we're okay with that. So now if you see, we can have a package.json here. And our main entry point is going to be this index.js file. So what we'll want to do is make an index.js file. And then we're going to open VS Code into this folder as well. So if you have VS Code installed, you can run the command code and then dot to open a VS Code window in your current directory. There we go. So now we have our lesson 13 folder with our index and our package.json here. So perfect. Now, if we want to open a terminal inside of VS Code here to make it a little easier to see, I'll make this full screen for you guys. And so now the next step is to install some of the packages that we're going to use in our Node application today. So how you do that is npm install. We're going to run save to save them as dependencies in our package.json. And then what we're going to use is express as our server, cores, which defines how different websites can access our backend, what different IP address can access our backend, mongoose, which is going to be the package that lets us interact with MongoDB. Then we have this another one called bcrypt.js, which is used to encrypt passwords. JSON web token, which we're going to use to create web tokens that can verify users. And then another one called express validator, which is going to be used to validate different entries and different user inputs into a API request. Then a couple ones that are kind of not necessary, but are really good to use if you're doing your own project and are really useful. The first one's called NodeMon. What NodeMon does is it lets you run your web server, and every time you make a change on your web server, it automatically stops and restarts your application. So you don't have to constantly do Control-C and then run node index.js again. And then the last one is called .environment.env. And what that lets us do is access a .env file where we can store different variables that we want to use across our application. So as these get loaded in, I want to talk a little bit about what this JSON web token is. So let me also run, actually, that's all we need to run for that. So with that, let's talk about JSON web token. So the way a website remembers who you are is by using JSON web tokens. So you send your login information through an API request to the server, and then the server processes that login information and then creates a unique JSON web token that has an expiration date and sends it back to you. And then the next time you want to access the server, you will use the JSON web token in one of the headers inside of your HTTP request. And the server will then validate the JSON web token to make sure it's not expired. And if it's still valid, it will then return the response that you're looking for. So in this example, if we have an API to sign up at api/auth/signup, we can send our username, email, role, and password. And then the server will check to see if the user already exists. And then if not, it will save the user to the database. And then when the user wants to log in, he can send his username and password, which will then be authenticated on the back end to make sure that it's the correct username and password associated with that user. And then they will receive the JSON web token back. And then on their next time they need to access a resource, they will send the JSON web token through their x-axis token header, which the server will then check. And if it's still valid, return in all the content they want. So with that understanding, we can start code in a little bit. So to start off, we want to import the different packages that we are using. So we have Express. And then we are going to use a body parser package. Oops. Question in the chat. The client automatically stores the JSON web token, or do we have to manually store it? So when you design your front end application, the client will be the front end application will store the web token for you. And where that could be stored is in your local storage on the computer or in something called session storage, which I can show you a little later too. So it's going to be stored on the front end and then sent across in every request to the back end to be verified on the back end. You don't want to verify it on the front end because that can introduce a lot of different security vulnerabilities doing that. I'm following along, but for MongoDB, do we make a shared cluster? Yes, if you want to follow along, you can either make a shared cluster on MongoDB, or you can install Mongo SH, Mongo's shell command line interface locally, and then use the local example. Either one works for this. I am going to try to use the shared cluster online. And if that doesn't work, then we're going to go back to the in-person or to the local MongoDB database instead. Okay, and then with these, we want to create our app like before. And then we're going to also choose a port that we want to use. And then we'll create some of the middleware that we're going to use. So using our Express app, we're going to parse the JSON that we get from a request to make it readable. Oops, that's supposed to be, I did this backwards, sorry about that. Body parser.json. This will parse the JSON that comes in our request to make it readable for our server. And then we'll create our routes. Okay, so this will be our default route just to make sure the server works. And then we can say API working. And then besides that, we want to let the app listen on the port that we described. And then let me close this off. When the app is listening, we can log that in the console. There we go. So this is a very basic application. Like I said before, we installed this package nodemon. And what that's going to let us do is automatically restart our server whenever we update anything in our file system. So instead of doing node index.js to start our server like we normally would, we can do nodemon index.js. Oh, uh-oh, I must have done something wrong. Oh, I just did a little spelling mistake. There we go. So you can see I fixed an error and I saved the file, and then automatically nodemon restarted doing the changes and then started node index.js. And then we see in the chat that server started at port 4000. So if we go over to Postman, we can make a request to our local host 4000. And we should see a message here that says API working. Is it possible to zoom in a little? Yeah, totally. There. How is that? Is that better? Yep, awesome. I can zoom in more too if you guys want. Okay, so this is the basic Express app that's working. What was the command to start index.js? We installed the node package nodemon right here. So it's node mon. And to start the application using that, we did nodemon and then index.js. What was the localhost command for Postman again? It says the term nodemon is not recognized as the name of a commandlet. Did you run npm install nodemon here? Yeah. Did you do -- save? Yeah, all the same. Okay. That might be run on Windows. that could be a error in installing Node. If it works with regular Node, if you just do node index.js, I would stick with that for now. And then maybe comes office hours, I can help you with that. What's the localhost command for Postman again? Yeah, so for our localhost command, localhost just refers to our local IP address. So it would be 1.2 or 127.0.0.1 is the same thing as localhost. It's shorthand for just the default address on our computer that only we can access. And so that's going to be the default address that all our applications will run on until we actually host it on a domain. And can you explain the difference between require and import? Oh, so that's kind of a tricky one. I'm not exactly sure of the exact difference between them. I think when you require different packages that you use, it'll create an object out of that you can then use. And then if you're making, so actually require is going to be what you're going to use on a backend. So if you're making the backend, you're going to use this to import different libraries and different objects that you're going to export from different modules inside of your application. And if you're working on the front end, you're mostly going to import things if you're in React, like different components that you're going to use. So that's the time you'd probably see React import and require the most. If you want like the full definition, I would look up on Mozilla's docs for their specification of when you use require and when to use import. So for the graph you showed, the client sends username password directly like that without caring about being hacked. Yes. So the reason that they don't have to care about being hacked is when you connect to a website using a HTTPS like this, the S stands for secure. So what that means is the internet connection is using TLS, which is transport layer security, that encrypts the traffic that you're sending across the internet. So if a hacker sees your traffic across the internet, they won't actually be able to decipher it since it's all encrypted. So in your HTTP requests and responses, you do not have to worry about encrypting things since that's already being handled for you using TLS. Okay, let's keep building a little bit. So the next thing I want to do is create our MongoDB server. So how we're going to do that is if you've installed, we're going to open a new terminal down here to use. So we have our server that's our terminal that's running the server, and then we're going to have another terminal here. And to use MongoDB, you have to install MongoDB locally on your computer. So to show you the steps, I've already installed it on mine, but I can send you the link if you want to follow along at home to installing it. Let me just find it real quick. So here in the chat, this is the link to install Mongo SH, which is Mongo's shell scripting. If you have Mac, it's pretty easy to use with Homebrew, and then Windows has its own instructions. But the command we're going to run is Mongo SH to open up Mongo's shell. So here we have that Mongo's shell open up here. So we can see we're connected to a MongoDB database on our local host with this port address. And right here is the name of the database we're currently connected to. So when we want to use this, we are going to use this as the name of our database that we're connected to. So in our file structure here, we're going to make a new folder called config. And inside of our config folder, we're going to make a new file called database.js. And this will store the information about our database. So here we're going to start using Mongoose, which is what we use to interact with our MongoDB database. So we're going to import Mongoose using require. And then we're going to have a variable that represents the URL of our database. So Mongo uniform resource identifier is equal to, and this will be this right here that we have that's connected to the first part of that. And then at the end, we're going to have the name of our database right here, which is test. So this is saying that we have a database at this IP address that is named test. And then we are going to create a initiate Mongo server, which is a function. And this is the function that we're going to use later in our index.js. So inside of this function, we are going to use Mongoose to connect to our database. And then this new URL parser will let us parse different URL query information. And then after we've connected to the database, we're gonna log that we've connected to it. Okay, and if there's an error in connecting to the database, we want to catch that error. And then log the error that we have, and then throw that an exception there. And then to use this variable outside of this file, we want to export it. So we'll use module.exports and then set that equal to the variable name that we want to export. So to recap, this is the IP address of our database. And we're going to create a function here that is an asynchronous function that tries to connect to our MongoDB database. So with that saved, we can go back to our index.js, and then we can import the variable that we just made. So const initiate MongoDB server is equal to require and ./config/database. So now we want to initialize the server, which we can do with initiate MongoDB server by calling that. So if that works, we should see that the server started at port 4000 and that we are now also connected to the database. So that means everything's good right now. So now let's start creating the schema for our database. What the schema is it's what our data is going to look like that's being stored inside of our database. So we are going to create a new folder called models. This will store the different schemas that we have for our database. And inside of models, we're going to create a file called user.js. This file is going to represent what a user looks like that is being stored in our database. And it's going to define the different parameters, the different variables that are associated to a user. So again, we're going to require Mongoose in this file since we are connecting to MongoDB. And then we can define a variable called user schema, which using Mongoose's variable names, we can create a new schema here. And this new schema is going to define those key value pairs that we have. So the first one's going to be a username. So this is going to be the key here. And then it's going to have some metadata about it, which is the type of that key, which means we're storing a string. And then we can have required set to true, meaning that this variable has to be present when we want to create a new user. Similarly, I'm going to copy and paste this. We're going to have a email field, which is also a string and required. And then we want to have a password, which is going to be a string. And then the final one is created at, which is going to be a date, and it's going to default to date.now. Okay, so to recap, this right here, this variable is defining a schema for a user that we want to store in our database. And these are going to be the different keys that are associated with our user. So to export this, we're going to again call module.exports. And then we're going to use Mongoose's notation to export a model called user. And we're going to pass to that the object that we created, which is user schema. So this might seem a little weird because we're using this Mongoose library that has a bunch of different things. But to get a good recap of how Mongoose works, you can go look up Mongoose online, and they'll have in their documents the exact definitions of what all these different components do. What is a schema? Is it similar to column headers in an SQL table? Yeah. So if we look back at our example here, this is the Airbnb listings, and we have these key value pairs here. So the schema for these listings is going to be listing URL, which is going to be a type string required equals true. And then we have name, which is a type of string required equals true, and summary, and so on and so on. So like you said, the schema is very similar to column headers in the SQL table, as it's going to describe what the pattern of our information looks like. Can you explain the last line? Yeah, so we want other files to be able to use this model that we've created here and that we've defined here. So what module.exports does is it lets other files use information that's inside of our file here. And what mongoose.model does is it then uses our schema right here to define a model that we've named user that follows this user schema. So this will become a little more clear as we use it in some of our different routes. Are there any other questions about this? Okay, what is like user? Yeah, so that's just a name we are assigning to the model. So when we use the model later on, we are going to, that's basically just like a unique identifier for our specific model, because right now it doesn't really have its own name. Got it? Awesome. Perfect. So the next step is we want to define the routes that we're going to use for authenticating a user. So when we have a larger project, we want these to be a little more structured. So we're going to create a new folder called routes. And inside of this, we're going to define a route called user.js, which is what the user is going to use, or is where our routes are going to be, is where we're going to store our routes about the user. So inside of this file, we're going to need a couple things. We're going to import Express again. And actually, before we do this, to make this a little more clear how this interacts with the rest of our application, we're going to, in our index.js, after we have our app.get slash, we can then define other different schemas that we want to use. So that seems, okay, that sounds a little complicated, but instead of having all of our paths inside of one file, we could define other files that will handle other URLs inside of our application. So if we do app.use, and then we want to use /user here, and we're going to point that to user. And this user right here is going to be our route /user. So we need to import that up here. Okay. So this is an example of routing on your backend. Oh, it's not like that one. Okay, so we haven't fully implemented users, so that's why it's getting it's got mad about that. But to recap on how this works, as a URL, as an API request comes to our backend, it goes down this list of app.uses. So the first thing it hits is app.use body parser.json, and that's going to parse the body of our API request, of our HTTP request, and convert it to JSON. And then that's going to get passed on to app.get. If it matches if the URL matches just a slash, so an example, if it's just a slash like this, then that's the app.get that we're going to use. It's going to then call this right here. Otherwise, if it doesn't just match a slash, it'll check the next app.use or app.get. And in this case, it's /user. So if the API request, matches /user and then anything after it, then the app is going to pass the HTTP request to this user file here. So that's what we're going to implement in our user file, is all of the HTTP requests that start with /user. So the first one is going to be, the first thing we need to do is create our Express app. So we import Express, and then we create an object called router, which is equal to express.router. And so this is going to act the same as how app would work in our index.js. So with our router, we can make a GET request, or we can define a GET request or a POST request. And in this case, we're going to define a POST request, and it's going to be the path /signup. So if we get an HTTP request that is /user /signup, this is the function that is going to be called. So with that, we can then define, like we would in an app.post, we can define an async function here that takes the request and returns this response. And this will be ran every time we run /signup. Okay. So inside of here, we want to get the different variables for our signup from the body. So when a user signs up, we want them to have a username, an email, and a password. And we want them to pass that in their body. So for an example of what we're our end game here is a user is going to make a request to this IP, to this URL, and in our body, they're going to pass in a username, an email, and a password. And then we want to give them back in return a web token. So here we have the username, or here we get the username, email, and password. And then we are going to see if there's already a username in the database, that username is already in the database. So we're going to we need to import our model for user here. So this is the model that we defined earlier that defines the different properties that a user has. So it's in the models /user folder. And then inside of here, we can use this model and run a mongoose command called find1. And so what that's going to take is the email that we have. And if there is a user with this specific email, then it will add that, it'll assign that to the user object here. So this .find1 is the command that we're using to access our MongoDB database. And we're accessing this user schema that we defined for the collection, which is similar to in an SQL database. This would be a table, and we are finding one where the email column matches the email that the request has. So if there is a user in the database already, then we want to return a response, and it's going to have a status of 400, which means that the client did something wrong since it's trying to make an account with an email that already is in the database. And then we're also going to return JSON along with that response. So here we can return a message that says user already exists. Okay. So if this user doesn't exist, then we want to create a new user in the database. So we can assign user to be a new user. And the user will have a username of username, then their email, and a password. Okay. And then when we save passwords in a database, we don't want to save the raw version of their password, or else if our database gets hacked, then that password can be exposed to the hackers, and that could cause a massive data breach on our end. So to kind of get around that, and we want to encrypt the user's password and hash it and store that hash in our database instead. So we're going to use the library imported earlier called bcrypt.js. So we're going to make a variable called bcrypt. And with that, we are going to encrypt the user's password before we store it in the database. So const. So if you've taken 161 before, computer science 161, there's something called a salt. And a salt is a random number that we use to append to a password before we encrypt it. And all this is really doing is making it a little bit harder for a hacker to find out the password. If you're interested in more about computer security, you can look up password encrypting with salt, and there'll be a better explanation on how and what's going on here. And then we are going to encrypt the password. We're going to hash it with our password and our salt. So what these lines are doing is the first line is creating the salt, is generating a random string of numbers. And then the second line is using this bcrypt library to hash our password and salt together. And this is creating basically a random string of numbers that were stored and the user object for their password. So now that we have this user object created, we want to actually save it in the database. So we are going to call user.save. And this is the function that will actually update our database. Okay. Any questions on saving, creating new users, stuff like that? Okay, since you did require models/user, this is referring to the user.js file and models, right? Not the user identifier we used to name the database table. Yes. So this user right here is referring to this file right here. And this file is exporting a model here that has a user schema. So it's directly referring to that file name. Can I include username, password in the URL of the post request instead of in the body? That's actually a good question. If you include it in the URL, I think that traffic is not encrypted. So a hacker who has access to your request will be able to see that. So I would try to refrain away from including sensitive information in the URL. Most of the time you want to include that in a body or inside of a post because that data will actually be encrypted. That's a really good question, actually. Is salt similar to seed? In a way, yeah, it is kind of similar. So the kind of general idea is you have your password, and then if it's an insecure password, like only like 3 characters, you want to append like 50 random characters at the end of it to have a more random generated hash. And then that hash is what you're storing. So it kind of increases entropy in a password, and it makes it harder for a hacker to guess the password. How is the find one method being used then if it isn't defined in user.js? That's a good question. So when we created our user object here, this mongo.model, MongoDB has this function called find one. So this function is defined in Mongoose's schema, and it's used as a way to access the database. So this isn't a function we have to define. This is a function that is already in the Mongo library, basically. And we get access to that by importing Mongoose in here. So this is just a property that we're going to have after we run this command. There are a lot of other properties too. If we go to the Mongoose documents. So if you were interested in learning more about Mongoose, this is a great resource for that. So here we can see the same type of thing as what we just did, making our schema. And then let me see if I can find a good example. See, instead of finding one, we can just call .find instead. And this would let us find multiple objects that might match the same thing. And there's different versions if we want to find something greater than, something less than. And to find all those different types of functions, you can look through this Mongoose document right here. I can also drop this in the chat for you. There we go. Okay. Are there any other questions before we move on to creating a web token? Okay. Feel free to ask any questions about this later on too. I'm happy to answer anything at all. So as you can see here, VS Code is getting a little mad. We don't have a catch statement in our try block. So we can add a catch statement here, and we can console.log this error message. And then we can also return to the user, in this case, the client that made an HTTP request. We can tell them that something went wrong on our end, which is what F500 means, is something went wrong on the server's end, and then send them the message, error and saving. Okay. So the next thing we want to do is create a JSON web token that we're going to return to the user. So we want to import our JSON web token library, our package. So we'll create a variable called JWT and then require JSON web token. Okay. So after we saved the user to the database, we're going to want to create the web token that's going to be returned back to our client here. So here we'll create a payload, which is another term for the body of what's going to be sent back to the client. And this payload is going to have a user object inside of it. And the user object is going to have an ID that's equal to user.id. So this ID right here refers to the unique identifier that MongoDB assigns to our entry. So if we look inside of our example right here, this entry has an ID of this number right here, and that's what we're referring to. This number gets automatically created with every entry that we put in the database, and it's always guaranteed to be unique. So you don't have to add this yourself. Okay. So now that we have this payload created, we are going to use our JSON web token library to create a new token. And that's with the sign command here. So we're going to pass in the payload that we want to sign. And then this is a secret or private key. This is used on the backend to guarantee that to check that you are the one who signed the web token and that not somebody else made this web token. So here we can put random string. And then finally, we also specify how long the token has to live. So we can have an expires in property here, and we can say 10,000 seconds, meaning that this token will be valid for 10,000 seconds. And then after we've done that, we can have a function here that checks if there's an error in creating this token. So if there's an error, then we want to throw the error. Otherwise, we now have this token that's been created after this command, and we want to return that back to the client. So in our response.status, we'd say a 200 response, meaning everything's okay. And then in the JSON response, we want to send in our token. Okay. So to recap, this function is going to create a JSON web token. A JSON web token is going to encrypt this payload. It's going to use this random string as a secret that only the server knows. And then it's going to also specify this token is going to expire in 10,000 seconds. And then after it's created this token, it's going to call this function down here. This function has an error and a token. If there's an error in creating this token, then this will be not null and we can throw this error. Otherwise, we can return back to the user a status of 200 and return the token. Okay. That looks pretty good so far. So if everything goes to plan, then we should be able to sign in, or we should be able to sign up with a new username. The last thing in this is to define our module.exports, and we're going to export our router to index right here. So again, we created this router up here as an express router, and we're exporting that as our user route. So in index, when we import here, we're getting that router object that we exported. Okay, so now we can see that we have this test server that's running still, this test database. Our port is 4000 for our local host. So if we go to Postman, localhost 4000, we can then go to the route user/signup. And if we want to make a user, and then in our body, we specify the parameters that we need to make a user, which is a username, an email, and a password. So if everything goes to plan, we get back a good response. You see the status is 200 here, meaning okay, and we get the token back here. So that's great that we just made a request to our database and then got a valid response too. So that's awesome. So to give you a little more insight about what's going on in this token, there's a website called jwt.io. So here I can paste in our token right here. And this will kind of show you what's actually being encoded in this token. It may look like a bunch of random numbers, but it actually corresponds to our user right here. So we can see this red right here corresponds to the algorithm that we're using for encryption, which is HS256. We're making a JWT token. Oops. And then our payload, which we defined on our backend, has the ID, has a user object with the ID that we specified, and then also has a time that it's been issued at, and then the time that it's expired to. What happened if you didn't include the random string in jwt.sign? That's a good question. So here, this blue part right here corresponds to a verification of the signature. So what this means is if, for example, we want to try to verify it with something else, like say we had password, if we didn't know what the random string was, then when we paste in our JWT token, down here we can see that it's an invalid signature. So this might be a little complicated for this class, but if you take CS161 computer security, what an HMAC is doing is it's verifying that this payload is what we think it is. So what random string does is it's used as, in a sense, a password on our data to make sure that what is inside the JSON web token is exactly what we specified that it is. And it's used to verify that our server is the one that created this web token and that somebody didn't just go in here and like change some random variables and stuff. Because if somebody did change it, then we'd be able to check the signature and see that it's invalid. But since we did create this token and we know what the random string is, then our signature is verified down here. So for example, that would stop somebody from creating their own web token with somebody else's user ID here and then getting access to their account. Oh, that means no one can hack even if they can use this app to decode the token. That's because they do not have the random string. Yeah, exactly. So if, for example, the front, we did leak the random string somehow, then people could make their own JSON web tokens using the same process we did. And you send those and pretend to be other people when they log into our backend. But since we have this random string that the user doesn't know about, that the client doesn't know about, then they can't create their own web tokens. Okay, I see that I have 20 minutes left, so I might have to go a little faster through the rest of this stuff, but please keep asking questions because those are more important than going through all this content. Okay, so we have a web token here. And the next thing we want to do is create a login route so the user can log into their account that they made. So inside our route here, we have a post route. And then we also, for signing up, and then we'll create another route for logging in. Okay, so this will handle when the user wants to log in. And then here we can check, well, here we'll run this function when the user wants to log in. Oops. Okay. So here we can get, so when the user wants to log in, they're going to log in with a username and password. So for example, here's the request here. It's going to take an a username and a password. So we're going to get the email and password. We're going to get the email and password from the body of the request. And then we're going to try and see if there is a user associated with that email, like we did before. So we can copy and paste this. And then if there is not a user this time, when you try to log in, then we want to return a status of 400 and specify that the user does not exist. Okay. Otherwise, if the user does exist, then we want to try and verify that the password is correct that the user is using to try to log into this email. So we can create a Boolean variable here called isAmatch, and we're going to use the bcrypt library again to compare the password that the user gave us with the password that's stored in the database. So the reason that we use this bcrypt library compare function here is we are storing the user's password as a hash that would be encrypted with a salt. So using the library, we'll be able to compare the password that they try to input here with this hash version of the password and check that they're the same. So if it's not a match, then we want to return an error. that says that it's an incorrect password. Okay. Otherwise, if it is a match, then we can go ahead and log the user in and then give him a web token. So again, we're going to create our payload that has our user ID, like we specified before. And this is coming from this user object up here. And then we're going to create another web token the exact same way that we did before, like this. I spelled this one. Payload. So this will create another web token. And maybe this time we want this to expire a little earlier. So we can let this expire in about a weekish time. And if there's no error, then we want to return this web token back. Otherwise, we want to have the same, we want to catch another, if there is an error, we want to catch it and tell the client about that. So this is our login route complete, just like that. And if we want to test this out, we can make a post request to user/login. Here we have the same email address that we stored here, will1@gmail.com, and then the same password. And we can send this request and we get our token back again. And this token is actually going to be different than the before, since it's going to be issued at today's date and time, since we just created it, and it's going to expire in 360 seconds. So we can see too that this works if we change the password a little bit. We can see that we get the message incorrect password. Any questions about that? Why can't we use the previous token? So we can use the previous token if we wanted to. The user will be able to use that token until that token expires. So if that token expires, instead of signing up and creating a new account, instead of creating a new account for the user, we want to instead sign them back into their original account that's already associated with a user in our database. So that's the reason why we have two different functions here. This one is to create a new user with the username, email, and password, put that user in the database here. And this route is used to log the user back into their account if their token has expired. So this finds their account, makes sure that they own the account by checking their password, and then creates a new web token for them to use to stay logged into their account. Okay. Any other questions about that? Okay. Perfect. So the next route that we're going to make is going to be our authentication route. So this will be a route that gives us to lets the user send their token, and then on our end, we can check that the token is valid. And if it is, then we can give the user back data that only they have access to through their account. So to do this, we're going to make a new route down here, which is going to be a get route. And it's going to be called /me. So this is going to tell the user some information about them, basically what we have stored about them. And so this route's going to be a little different. It's going to use middleware, which is going to be called auth here. And then it's going to call our function, which is the request response function here. So this is something you have not seen before. So I can take a second to go over it. Like I was saying earlier, as our app progresses, it goes down the list and runs these middleware commands, is what this is called. So the middleware is a function that takes a request and a response and then does something to the request and the response. That's what middleware is. And then passes it on to the next function in the list. So here we have a body parser. We didn't create this one, but this all it does is parse the JSON and then send the request down the list to the next thing. So what we want to do is create our own middleware in this route that we use before we run this route that checks the authenticity of the web token. And the reason we're creating middleware for it is so we don't have to duplicate the code of creating web tokens, of checking web tokens every single route that we have. So this is a way to simplify our routes a little bit. So to do that, we'll make a new file, a folder called middleware. And in this folder, we'll create a new file called auth.js. So this is going to be the file that specifies the middleware that we want to run. So we're going to import our JSON web token here, our JSON web token package. And then we want to export. So like we did at the other functions, we're going to modules.export, and we're going to export a function that takes a request, a response, and a next. And this next is special to middleware functions. So what is basically going on is we are going to run code in here to do things with request and response. And then at the end of all the code we want to run, we're going to call next. And this is going to pass on the request and the response to the next function in the line. So in our example here, it's going to run the code that we're going to put here and then pass that on to this function here to keep running more commands. So this code is going to be responsible for checking the authenticity of the web token. So we want to get the token from the requests header. So we can use request.header here and then get the value associated with the key token. And if there's not a token, then we want to return a 401 status, which is like a not allowed status. And then we can just say, we can have a message called authentication error. So if they don't include a token in their headers, then we don't want to allow them into our service. Otherwise, we're going to try to decode the token. So here we can use that JSON web token package and call verify on the token. So we will pass in the token that we got from the header and then also our secret string here. So again, this random string is something that we only know. So we are passing it in to verify to ensure the authenticity of the token and that we are the ones who created this token with this random string, not somebody else. So when it's decoded, it's going to kind of look like this a little bit. It's going to be this payload object right here is the decoded version of the token. So we can see that it has a user field here and an ID. So in our request, we could then create our own variables in the request. So we can create a variable called user, and we can set that equal to the decoded user object from the web token. And then if everything works there, then we can call next to keep the code running afterwards. And this will call the next function in line. Otherwise, we want to catch an error. We want to log the error and then return a 500 status saying that there was an error. Okay. So this is an example of middleware. Is there any questions about this real quick? Okay. So now that we've exported this function here as our middleware, we want to import it into our users page. So we are going to add that down here as an const auth is equal to require, and then the middleware that we just created. And then now this variable right here is the one that's getting passed into the /me route. So when this route gets called, it's going to pass our request into authentication, run this middleware here, and then we can modify the request throughout this. And then it's going to call next, which means we're going to be back here inside of this function with our newly modified request. So to finish this off, inside of this route, we want to try, and we want to get the user from the database and then return the user back to the client. So we'll try to get the user, which is we use the user schema, and find by ID, which is another mongoose command that we can use that can take a user ID. So this is the ID that we got from the user object right here. And again, the user object has a variable ID here. And once there we go. If the user exists, then we can send that back to the client as JSON. Otherwise, we can catch this error, and then we want to send back a message. And then this is going to be an error in fetching user. Okay. So we can see that the server's back up. We've created this new route. So let's see if our new route works. Here we have Postman again. Here's our route for a user right here, /user/me. And again, we want to add a header to our route that has the token inside of it. So from when we logged in, let me put the right password back in. 1, 2, 3, 4, 5. Here's our token right here. We want to set this as our header for token. Oops. So we can edit this header field and put our token in there. And then if we send this request, we can see back that we get our user object, which has our ID in it, our username, email, and then the hashed version of our password that we saved, as well as when we created our account. So just like that, we've had a user create an account, save their account. Then when the user wants to log in, we can give them a JSON web token to prove that they are who they say they are after they've logged in. And on every subsequent request to our database, whenever they want to access things that we want only them to be able to access, they include this token header right here, as well as their token. And this ensures that they are who they say they are, and that then we can then give them access to private parts of our website. And that kind of completes the whole ecosystem of how we have user authentication. Is there any questions? The token isn't automatically stored in Postman, but browser. So yes, in your front-end application, you're going to want to have the browser store the token. So you're going to have to specify that in the browser, in your front-end application, and specify in your request back to store the browser. And there's different packages you can use to make that easier. But the general idea is when you make a request to the backend or to our backend, you need to include this header. So you can use some packages that make that easier and automatically include it. But if you're just making a fetch request, then you need to specify headers and this token header. Does that make sense? Perfect. Awesome. That concludes what I have today for this lesson. I see we have 2 minutes left, so if there are any other questions, please let me know. And if not, thank you guys for coming and sticking through this. I hope it was valuable to you. And I look forward to seeing you later. One last question. If someone works for a specific project and tells other about the random string, the information of all users will be lost. So yeah, so usually it wouldn't be such a thing as random string. It would more so be an actual random string of random bits and numbers. And it's kind of like a password to the database. So you can have this random string kind of change throughout time and have different versions of it. But the general idea is if a hacker knows about the random string, then the integrity of the JSON web token is compromised. Yeah. Awesome. Thanks for asking a lot of questions too. I really appreciate the audience and the back and forth. It's very helpful when I lecture. Awesome. I'm glad you did. Backend's awesome. Thank you for coming again. Yep. Have a nice night. I'll see you later.